general relativity, step by step. We've got this rather nice line element metric here. I'll pinch in a bit. We've got ds squared equals minus 1 over r. Of course, you'll normally see 2gm over r, but I can't be bothered to write that. Oh no, we've transformed it into p and q coordinates. Now, the problem is that when r equals 1, we've got some rather peculiar behavior here, because this term vanishes, of course, at r equals 1, and the sign changes. So what we need is a transformation. We need a p goes to some function of p, and of course a q goes to some function of q, that removes this singularity, or at least makes it more transparent. And it's not entirely obvious how to do this. There are a number of choices. I mean, you try a whole bunch of things. Part of the problem is that we are confusing r's here and p's and q's here. So what Kruskal, I think it was, who specified, was that p tilde equals e to the p over 2, and q tilde equals minus e to the minus q over 2, all the minuses. And of course we can transform that quite easily as well. We can specify that p equals 2 log p tilde and q equals minus 2 log of minus q tilde. So now when we look at our metric tensor, minus 1 over r dp dq, I want to express it in terms of p tilde and q tilde. So it's minus 1 over r times dp by dq tilde dq tilde for that term there. No, it isn't. That should be a p, not a q. P tilde times dq, this because they're just univariate transformations, by dq tilde dq tilde. And of course now we can substitute from these guys here. So it's minus 1 over r dp tilde dq tilde times these guys here, dp by dp tilde. dp by dp tilde is 2 over q tilde, and this one of course is minus times the minus is a plus 2 over, I keep on getting my p's and q's, I've got to mind my p's and q's, that's a p and there's a q tilde, that's right. So we've got minus 1 over r times dp tilde dq tilde times, oh well, I can just write it out here, over p tilde q tilde, which I can use these expressions for here. So we need to work out what p tilde q tilde is. Well, that is here, it's e to the p over 2 times e times minus e to the minus q over 2, which equals minus e to the p over a half p minus q. Is that right? Yeah, that's right. Okay, and we know what p and q are from, that's quite a long time ago. We know what p and q are. P and q are these guys here. So p minus q is just 2r minus log r minus 1. I need to scroll back and forth quite a lot. Equals minus e to the half of 2r minus 2 log mod r minus 1 equals minus e to the r times, sorry, that's a plus, r minus 1. There we go. That's quite nice, isn't it? So now I can substitute into this formula here. So I've got my line element is minus 1 over r dp twiddles dq twiddles over pq, which is minus r minus 1 e to the r, which equals various things will cancel here. Minus 4 over r e to the r dp twiddles dq twiddles, which is rather nice. You normally see this written as minus 32 gm cubed over r times x of minus r over 2 gm dp hat dq hat. But of course I'm using my nice units in which g and m just don't figure at all. Let's just go back to this formula here again. We've got minus 4 over r e to the r dp twiddles dq twiddles. Now the peculiar thing is that nothing peculiar, put that in scare quotes, it's not very mathematical, happens at r equals 1 by this rather inspired choice of coordinates here. This rather, where was it? This rather, where is it? It's this one here. This rather inauspicious looking coordinate transform just happens to behave exactly in the right way to cancel out the coordinate singularity at r equals 1. And we've got this rather beautiful system here. I'm going to stop there. That's nice, isn't it? Minus 4 over r e to the r dp twiddles dq twiddles. Super. Stop.